Hello, it is October 11th, 2023, and this is the bi-weekly libhal meeting. Now, we skipped last week's meeting because I was at C++Con or CPPCon, and I was really busy with networking and talking with people. Go into more of that probably the next 2 weeks. But for the agenda, I'm going to go over the items that I meant to go over last week, but didn't get an opportunity to. So we're going to be going over reducing boilerplate with CMake functions, writing better code with clang tidy, the new policy on how interfaces are inherited. The main idea is that only adapters will inherit HAL interfaces. I'll talk more about that in a sec. Introduction and usage of selector tokens, as well as singleton support. And actually, I can say this right now, I did not talk more about singleton support. I could actually say removing that from the agenda. For now, that's still being worked on. So, reducing boilerplate with CMake functions. So I knew for the longest time that the CMake files that we were making were pretty redundant. I did this on purpose. I wanted to see what variations we would have between things and what would kind of just stick. I felt like if I did that way too early, I would be writing myself into a corner, make things really difficult, and then have to break out of it and then come back into it. So I thought, let's just kind of spread out and see how things kind of form. And then once I figure out the things that we typically need almost every single time, I'll be better equipped to make a helper function. So although I think people should be allowed to not use the helper functions, we shouldn't try to develop something that works for everyone. We should just say, hey, use normal CMake, you should be fine. But for libhal libraries, since it also adds in some additional requirements on their side, it's really good. So let's look at what we had before. So typical CMake start project, find packages, your library file, and everything else that you need. And then also we have this add directory, which would also bring in our CMake file from the tests. And then from here, we'd have like a whole bunch of like enable ASAN if it's available or usable. Some things to check the compiler, and a lot of other settings here. These are all like very redundant, reused almost every single time. Almost everything here is the same except for what's contained in this block. On top of this too, there's one other thing to show, which is that in the Conan file at this time, we had our build step's kind of intensive. We have this little will run command indicating whether or not we'll actually run the executable built from the build here. We have some checks to see if it's Windows, and if it is, just configure it. If it's bare metal, we're going to say building's turned off, and if it's none of those things, then we enable ASAN, because technically that would be a situation in which ASAN is available, and then if you can run it after you build it. So there's a lot of things that go into this, and these were all copied and duplicated over and over again. Now, what I wanted to do is really get rid of as much boilerplate as possible. It may not seem this way, but I am thinking about ways to reduce the size of all this every single step that I can. I'm doing it slowly to make sure that we don't squeeze ourselves into a hole and then have a bunch of additional chaos. But I'm hoping that as time goes on, I can eliminate most of this stuff. I bet I can actually move a lot of this stuff into the CMake, although I'm still not sure if that makes the most sense, but still considering it. And this stuff would probably still have to be here because this is stuff that the package needs to have about itself. But now let's take a look at what it looks like now. So now we have this libhal test and make library. Give it your library name. Give it all your sources, your test sources, your packages, and then your link libraries. And that's pretty much it. There is no test directory. There's no CMake file in here at all. That's all taken care of by this. And then the actual Conan file, if you look at the build step, is very... Oh, this one hasn't been updated. That's weird. Wait, hold on. That should actually be... Is that still the same way right now? Let's check. Because if it still looks like that, that should be removed. I'm not sure why I didn't go back in there and remove that. Yeah, now it's just CMake, configure, and build. And that's it. So that greatly reduces the amount of code that was there before. We moved a lot of the build logic out of the package manager and into the actual build system. So that was better. And I think a lot of this looks a lot nicer. So, oh, and then one of the things to keep in mind is that One of the things I was thinking of was, oh, after we compile this library, we can take that library and we can link it against the sources so we don't have to compile less things. But actually, just like I probably told people before this who have worked with me, we actually need to recompile the sources twice. We have to compile them for the package. We have to compile them again for the tests. When we compile them for the tests, we add instrumentation or flags that will instrument the binary and provide things like code coverage and that kind of thing. So we need to compile it with the code coverage steps and stuff like that. Then we need to compile that differently for the library, which is going to be stripped down. It's not going to have all that extra stuff in there. Then we link both of them against these libraries. The test sources get linked against Boost UT. And then these are just the names, the extended names for the linked libraries. Now, if we take a look at the schemic util README, you can see all the instructions here. So it explains to you how to use it. That needs to be updated to be 2.11. Or I could just put something there as a placeholder. Shows you how to actually use it, what options you have with it. It kind of explains all of the different things inside of build outputs, such as the generate intel hex, generate binary, disassemble with source, print size information, full post build, and post build. Should reorder those. Then also some other things like optimize, debug, build. Then if you get a little lower, we can get to the build functions such as libhal, make, test and make library. We have libhal unit test. Unit test is specifically useful for header-only libraries like libhal itself, where we don't have any library to build, but we do want to build the unit tests. So that's what this is doing here. And then we also have make library. This is for things that there are no tests for, or we don't want to kind of build the tests ourselves, in which case we just simply make a library. This is mostly going to be there for the third-party libraries because we shouldn't spend the time. I don't think we need to spend the time to run their own unit tests to build their code. It's useful for us to do for our code, but their code is probably tested well. And I can just assume that they do have testing in their environment, that the code hasn't changed between the two. And we also have libhal build demos, which is here in order to make it a little easier to build out demos. And yeah, that's pretty much libhal CMake utils. That's the additional things added to it to really get rid of a lot of the boilerplate. Next up, we have writing better code with Clang Tidy. It has been years since Jason Turner told me to start using Clang Tidy for everything. I really should have started using it for everything really early on. It's not that slow. It does slow down builds quite a bit, but nowhere near as bad as it did with SJC Dev 2 when there were like hundreds of files. We had to compile every single thing every single time. Not in this case. Now we just build package by package. But one of the things that I really appreciated was it telling me problems with my code. For example, the first item here where we see float auto, and it says use auto when initializing with a cast to avoid duplication of type name. This is important because you could technically, depending on what warnings you have, Clang Tidy will probably find this as well. You can static cast float here, and then maybe even put like int here. Now it should say implicit conversion or like, maybe not conversion that you wanted, but you could store this value in here. Whereas if you do auto, it eliminates you being able to, it doesn't make that mistake. Side note, just reminded me of the fact that I remember there's at some point where people were scared of auto because they thought it would add code bloat, because they thought it was some sort of like let or var where it was like an anything variable, except for what it really is, which is automatically figuring out what the type is. Here's another message that I thought was really awesome. It said, first function call argument is uninitialized value. And I was like, how does it know that this power P channel peripheral ID is uninitialized? If you go down the stack, it says, okay, in this file, assuming peripheral 1 is greater than 1. Okay, so go down this branch, taking true branch, assuming this one is equal to 0. Left side is true, peripheral is not equal to 0. Taking false branch, P peripheral is not equal to 1. Taking false branch, calling setup, first function is uninitialized value. So what it did was it actually found in some of my code where there was an else if, but there wasn't an else statement or some way to kick out of that function. There technically was a spot where it should have returned an error, but in this case, I hadn't actually written that part in. So this straight up told me, yeah, no, you're at this point in the code, when you try to re-reference this, it won't be initialized, or try to utilize it, won't be initialized. So that's some of the cool things you can get from Clang Tidy. It can traverse your code and find issues, even though like they are decently separated away from each other. Here's another one where it says address of stack memory associated with local variable context is still referred to by global variable p upon returning to the caller. And this one is a little harder to see, but basically we can kind of tell that there's except status return new error expected. And okay, so this part here I think might actually be a glitch in Clang Tidy, because what it thinks is happening is that expected should be copied by value and be used by value here. But it's thinking that it's being copied by reference, and that I then try to return that reference up a stack. So this might be a little bit misleading, but it was interesting to see it make this kind of judgment call, because it kind of goes pretty far deep into how the branching has to take through try handle sum and some of the boost leaf stuff. So that's a thing. And then here's a little cute one. I didn't even realize that the find function could take a single character. That was interesting. It makes a lot. It's way more performant to do that, because otherwise you'd have to every time you try to find a substring, you'd have to also include the null character. Whereas if you do a single character and it knows it's a single character, it could very easily iterate through the entire string to find what you're looking for. So that was really neat, and I did make the change here. So that's pretty much Clang Tidy. Now, here's a new policy. Only adapters will inherit HAL interfaces. Now, any code that currently already inherits HAL interfaces, that can stay as it is. Nothing too crazy there. It's fine. Although we probably will make new driver classes for that and kind of deprecate the old stuff. But why? Let's take a look at HAL LPC 40ADC. It inherits HAL ADC. What we can actually do is go here. Go to LPC, source, ADC. Actually, let's go to include. We can see here that we have an ADC that inherits HAL ADC. Now, what happens when we want to add interrupt ADC? Let's say that we decide that the API for ADC is very close to the API that should be for interrupts, except for like one additional override function. So say we want to, handle both. We have a single driver that does most of the work. Well, here are a couple of the options on the right-hand side. One option is just to have our HAL LPC 40 ADC inherit HAL interrupt ADC, but then your vtable gets a little bit gross because it has to become a tree at that point. And you get this thing called a thunk, which is just a way to kind of separate out the different, I think it's the ways to separate out different virtual hierarchies. Is complicated, and it adds more weight than we'd want. And on top of all of this, in my opinion, it ends up causing multiple inheritance ends up being a really gross thing to deal with. So that's all to say that multiple inheritance is not a good idea. We could also create a interrupt ADC, but the problem with having another separate object is that it looks like we're going to end up, if we have more ADC-like things, then we're just going to end up having a bunch of drivers that do mostly the same thing. Maybe the better idea is to have one large non-virtual ADC driver and lightweight adapters. So this is the idea of only adapters inherit HAL interfaces. So if we take a look at the initializer test here, good, so we have test driver here that doesn't do anything in particular. And then I have a make DAC, which takes some entity param test driver and blah, 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 does some magic. But internally we have this thing take a DAC, or inherit a DAC. And all this does is we pass the test driver to this thing, then we can call the right function on it, and that'll act like a typical DAC. Then we can return it, statically allocate it, and return it. Now, the idea here is, rather than trying to couple the interface to all these drivers, we're just going to separate and have individual implementations for those interfaces based off that driver. My goal is to hopefully ensure that most things don't inherit almost anything, and that these objects and these functions can continue to grow and grow and grow. We could easily deprecate functions here and there. It won't cause too many issues. Then we can also keep these as they are. Where is it? Yeah. We can keep the make functions as they are and kind of just add more and more of them that separate from each other. So that's just kind of the idea, is that overall, I think it makes for cleanliness and to ensure that our code size is as small as possible. I think that it makes sense to allow you to create a single big driver and then put all your stuff in there. Or you can do the C API thing, or just have like separate APIs for things that are truly singleton or truly just by themselves. And this also lends itself to using C APIs as well. If we find a company that has a software development kit out that is more Apache or MIT related in terms of its license, we can just take their C APIs and just throw them into the make functions or into the adapters and handle them from there. So that is the new policy. And yes, it very much reminds me a lot closer to C drivers tend to go. Take your C API, call them within your interface functions. Okay, so we have an introduction and usage of selector tokens. So selector tokens are helper template objects that are used with factories and constructors to determine what a driver is at compile time. They look like this. So we have like a HAL bus with a number inside of it, channel, port, pin, and buffer. Whereas I think in buffer's case, I want that to be the size of the buffer that it allocates for itself. Now, the way it would be used with initialize, that you put initialize here for your object that you want to initialize, then you put in the port and the pin that you want. But also, the port number may mean something depending on what you're doing. For example, if you're using a UART, it would be the UART port that you're connecting to. Same thing with bus. It could be a bus for I2C, it could be a bus for SPI. Channel is usually used for things like PWM, ADC, DAC. So in general, we usually use the word channel there, but I could also see implementations that also take a port and pin rather than taking a channel number. And then buffer could be something that you add to like your UART driver to give it information about how big to create that object. Now, all of these are just they're really just templated objects that have no size. So you never actually save them. What you actually do with them is you have them be passed in as whatever their name is here, _param. This is the concept. You can put auto here as well, and that eliminates the need to put the template parameter up here. So now you can have a whole bunch of these throughout your constructor and not have to worry about keeping track of all the different type definitions and type names for all the different template items. We take a port param, then you can call it on itself, and it'll return back the value that you sent in this template argument. And if it's less than a certain number, you can basically evaluate it at compile time, and then you can spit out a message. So the benefit of this is that at compile time, when we construct certain things, we can actually see if someone's constructing something inappropriately from this point. We had this same thing when it came to factory functions, but this is kind of a good way to kind of standardize it across the board so that there's a common name. And at some point, I'm going to come up with the exact names for most interfaces. Like serial ports will be port. I2C and SPI will always be considered buses. Port and pin is for interrupt, output, and input pins, and then so on and so forth. So that would be the usage selectors. Now, that's pretty much it for today's meeting. I did not go over the singleton support, or at least for this video. So we'll be going over that in the next 2 weeks.